Good afternoon. My name is Won Ha Choi, and I am delighted to present SK hynix CXL devices that will target to enhance the scalability of memory system. First, I would like to introduce SK hynix's perspective and vision in CXL. So the reason behind the emergence of memory expansion interface is that we have to look for more ways to scale memory system. There are more CPU core counts than ever in history for better performance, which means that we need more total memory bandwidth and capacity than ever before, because there are certain bandwidth and capacity requirements per core that need to be maintained. However, techno-scaling limit in computing memory creates the gaps between requirements and capabilities, which will even grow more when the segmentation of application use cases are more clear than ever in recent application use cases. So you can see in the memory interleaved, in the general purpose, and the compute-intensive workloads, such segmentation means that closing that gap will be even more difficult. This is where CXL can be very helpful, allowing new values in memory solution beyond what is possible today in existing server platforms. Such value adds with CXL memory includes bandwidth memory expansion, capacity memory expansion, differentiation of memory media, differentiation of memory media controller, and memory as a service with memory tiering and pooling, which will eventually target to optimize data efficiency and data center TCO. On the later slides, I will explain each value add in more detail. First, on the memory expansion of bandwidth and capacity. So traditional server platforms have to face physical limitations in scaling out bandwidth and capacity. For example, in the CPU, currently can have attached 8 to 12 DDR by memory channels, but increasing that number of channels to 16 to 24 will be extremely difficult due to that physical limitations. This is where CXL memory module attached as a separate memory channel with PCIe can be very helpful in expanding the bandwidth. And also for the capacity expansion, we'll have to think about how the number of DIMMs per channel will have to decrease. Think about all the 3 DIMM per channel era you had in DDR3 and early DDR4. Now we have 2 DIMM per channel era. And for the higher speed of DDR memory, maybe 6400 megabps or higher, we'll have to think about 1 DIMM per channel era, which means you're going to have a very limited capacity expansion potential with the current local memory. Therefore, with the CXL memory module with high capacity, this is where we can expand more capacity with more scale. Next value add I would like to introduce is memory media differentiation. CXL interface is memory agnostic in nature and non-deterministic. So this allows decoupling of memory media characteristics from CPU, meaning that any CPU that has to have a DDR5 attached does not have to have DDR5 attached in CXL memory module. So you can mix different types of memory media, such as standard DRAM, such as DDR5 and DDR4, or custom DRAM optimized for CXL, or processing in memory media, persistent memory, or hybrid combination of multiple types. So such differentiation can provide various design trade-off options in performance, capacity, and power on different use cases from end-user appetite. Next point is about memory media controller differentiation. So there are many CXL controller opportunities these days. And of course, there are common attributes such as front-side IPs in the CXL controller, PCI PHY, backside IP such as a memory controller and PHY that needs to be there for the CXL controller. But there are differentiation points such as ECC and enhanced RAS features, security features that can be consistent with the host enhancement in the security, low power features, computation acceleration features, and vendor optimized features. And with such differentiation, we can create a different combination CXL memory solutions as shown in the example on the right with the computational memory solutions with the CMS engine attached to the controller that can provide more values. Last value add I would like to highlight is about memory as a service. With the memory pooling, in reality, we can populate with different types of memory media, building composable rack scale appliance shown in the diagram. So we can have a disaggregated memory pool composed of a DRAM down memory module with CXL, storage class memory CXL module, or some card with DRAM DIMM slots attached. So we can choose different memory types and allocate variable memory capacity through memory virtualization. Now I would like to introduce SK hynix CXL devices and how to enable these devices. First, I would like to highlight about how to enable these CXL devices in the data center industry. Happening right now, we believe the first step will be the ecosystem enabling stage of CXL by evaluating pilot CXL devices, focusing on first launch and time to market. And the example will be CXL 2.0 on PCI Gen 5 and by 8 or by 16. Form factors will include adding cards with DIMM slots available, and there are EDSFF E3.S available in various demos in the industry. And we believe that standard DRAM such as DDR5 and DDR4 will be the first ones to use. And currently we are developing some memory standardization process with several MOUs between many standard bodies, including the MOU example between JEDEC and CXL Consortium announced recently. Next step will be market expansion, which we expect it to happen in 1 to 3 years from now. This is where we will actually see productization of CXL memory, introducing some value-add features. This is where you can see some variation of CXL versions and PCI versions, where you can have CXL 2.0 on PCI Gen 5. Some may think of CXL 3.0 on PCI Gen 5, or maybe CXL 3.0 on PCI Gen 6 at the earliest stage. We believe that E1.S will gain also more traction by then in order to allow more expansion of CXL adoption in 1U servers. We believe that more optimized memory for better TCO will start to appear around this stage, and we will start utilizing this memory standardization outcomes. After 4 years or more from now, we see the CXL market flourishing with value addition introduced, expanding value add features with stronger RAS and security, near memory processing, fabric attached, and memory as a service. This is where we expect CXL 3.0 plus on PCI Gen 6 and by 4 or by 8. We expect wide variety of form factors, not just EDSFF, but we may have to think about putting some OCP form factors in the future. We don't know. And we believe that we will be able to fully utilize and optimize features from memory standardization. So as an example of various POCs featured in our booth, first, I would like to introduce CXL Memory Type 3 device. I proudly introduced the development of first DDR5 DRAM-based CXL memory module samples. So this POC sample was announced originally in August 1st, and this features DDR5 class bandwidth, DDR5 class latency within 1 NUMA hop, and we believe this outperforms all in bandwidth per dollar and bandwidth per power among all the bandwidth memory expansion modules with the most cost-effective single die packages, not 3DS. This module features 96 GB E3.S with the CXL 2.0 on PCI Gen 5 by 8. This is based on latest tech node of DRAM with the 1A nanometer DDR5 24 gigabit single die packages. We target production of this actual customer sample by 23, and we have POC sample available now. So please contact us if you are very interested in evaluating these POC samples. In the booth, we have some performance data available in the demo. So the demo system has a 2-channel DDR5 4800 with 64 GB per channel, and DDR5 4800 CXL memory module with 96 GB. And with our experiment results, we see up to around 50% memory throughput improvement in MLC workload under 2 read, 1 write case. And we are able to discover around 20% improvement in execution time in the spec workload. And we were able to see capacity expansion up to 60% in the Redis workload. And also we have a heterogeneous memory software development kit called HMSDK exclusively for CXL memory devices. This maximizes system memory bandwidth with bandwidth-aware interleaving without software modification. So currently, you will have to do evenly interleaving between the host memory, local memory, and CXL memory. However, with this bandwidth-aware interleaving, you'll be able to allocate more opportunities for local memory to be interleaved better, to have a full bandwidth achieved with the available bandwidth. Next, I'm glad to introduce the computational memory solution, CMS prototype. So computing units integrated in the CXL controller targets the higher energy efficiency and thus more effective memory expansion. So this near memory processing engine will process memory-intensive ML/SQL operations, and that will certainly reduce data movement to or from CPUs. And there is a CMSDK offering data analytics library as an interface to in-memory databases. So with the collaboration work with SK Telecom in the in-memory database, this CMS applied experimental result demonstrates 30% higher energy efficiency alongside a lot better performance shown in the graph. And we have more CMS options with accelerator in memory called AIM. This AIM is not a CXL memory device. It's rather a GDDR6-based 8 gigabit DRAM package, but it can be attached behind memory-agnostic CXL protocol interface. With the 16 processing units per die or 32 per package, and 1 teraflops throughput available within the processing memory in-memory unit, more value will be added as massive parallelism will be offloaded from the host. As you can see in the diagram, up to 96% of the compute workload could be offloaded to AIM, which can achieve 2.3 times better runtime. So in summary, CXL has recently emerged as a more scalable and sustainable solution that will enhance memory system values such as bandwidth expansion, capacity expansion, memory tiering and pooling, and near data processing. SK hynix strongly supports CXL ecosystem, and we are absolutely committed to contribute to the industry by providing many efficient CXL memory solutions. SK hynix proudly presents the development of its first CXL memory module. This 96 gigabyte E3.S module is expected to target to maximize memory bandwidth alongside DDR5 local memory DIMMs. Furthermore, HMSDK will enhance the performance of CXL memory even further. I'm also very excited to present computational memory solution prototypes, including a CXL device with near memory processing capabilities and an accelerator in memory media based on GDDR6. So for more details on live demos and brochures, please visit SK hynix booth B25 for more products and demo introductions. And also, I would like to give you a sneak peek on the CXL forum tomorrow to learn more about the CXL memory solution. I'm going to talk about more on how to landscape the future for robust CXL memory development. Thank you, and have a great rest of the day.